Okay guys, we're going to do some notes on ions, a pretty short section of notes, and make sure that you have done your notes on element stability before you do the notes on ions so that you can refer back to those, because I'm going to ask you to refer back to them as we do these. So, ions. Okay, ions. Hopefully we can read that. Okay, first we're going to start off with a definition of an ion. Okay. And again, I'm going to read out loud what I'm writing, so if you want to listen and write, then you don't have to rely quite so much on being able to read the video, okay? So, ions are atoms that have lost or gained electrons, giving them stability and a charge, either positive or negative. Atoms that have lost or gained electrons, giving them stability and a charge, positive or negative. Okay. So with charge, well, let's just talk about that real quick. Okay. Losing electrons gives a positive charge. Losing electrons gives a positive charge because you are losing negatives. So for example, not an example, but kind of an analogy. If you lose negative things from your life, you're becoming more positive, right? So electrons have that negative charge. That's why we write E minus. You lose electrons, you're losing negatives, you're becoming more positive. Okay? Gaining electrons gives a negative charge because it's gaining negatives. Gaining electrons gives a negative charge because you're gaining negatives. Okay. All right, we're going to talk about two examples that we kind of keep referring back to as we do these notes. We're going to talk about sodium and we're going to talk about chlorine. So if you look at the previous page, the element stability notes that we wrote last time, okay, we're going to look at sodium and we're going to look at chlorine. And on that previous page, we drew a model, a rough representation of each of those atoms, and we talked about how they were not stable because of the number of electrons in their outermost layer. And those electrons are called valence electrons. So all of this should already be in your notes, okay? But first thing we want to talk about is, well, how many valence electrons does sodium have, and how many valence electrons did chlorine have? Okay, well, if you look back at that picture, sodium only had one valence electron. So I'm going to write 1 Ve negative, okay? It has one valence electron in its outermost layer, okay? Chlorine has 7 valence electrons. 7 valence electrons, so 7 electrons in that outermost layer of chlorine atoms. Neither one of these are stable. That's why we wrote unstable next to each of their atomic pictures, their diagrams, okay? So what are they going to do to become stable? Well, we talked about what gives an element stability, and that's the octet rule. 8 electrons for most elements, but really a full outer layer is going to be stability, okay? So with only 1, this is really far away from 8. So sodium's not going to gain 7 because that's a lot of work, okay? Sodium is going to lose 1 electron. So it will lose 1 electron. It will lose 1 electron to get to the full layer underneath. to get to the full layer underneath. It will lose one electron to get to the full layer underneath. So if you look back at that picture, if we take away that outermost layer from sodium, what's left is a full layer of 8 just underneath that, okay? And that gives it stability. Now, when it does that, it's losing a negative. So it's going to gain a positive charge. So it becomes Na, that's the symbol for sodium, but now that it has a charge, we're going to put a little plus up here, okay? You could write 1 plus, or you could just write plus, but either way, it's going to be a positive charge, positive 1, because it lost 1 electron. And it's called sodium ion. Sodium ion. Okay. So positive ions keep their name. So sodium loses an electron, it becomes a sodium ion, but it's still just called sodium. Okay. All right, chlorine, 7 valence electrons, super, super close to 8. Okay, it wants to be stable with 8, and because it's only 1 away, it's going to gain 1 electron. So it will gain 1 electron. It will gain 1 electron to fill its outer layer. It will gain 1 electron to fill its outer layer. So the things that are really far away from 8, they have 1 or 2 or 3 valence electrons, they're going to lose all of them and get to the full layer underneath. But things that are really close to 8, they have 5 or 6 or 7, they're going to gain however many they need to get to 8. So if they have 7, they're going to gain 1. If they have 6, they're going to gain 2. If they have 5, they're going to gain 3. Now we're going to avoid atoms right now that have 4 valence electrons, because losing 4, gaining 4, that's equidistant from 0 to 8, right? So we're going to avoid those. We're going to say if it has less than 4, it loses. If it has more than 4, it's going to gain. Now when it gains, it becomes negative because you're gaining negatives. In this case, it's gaining 1, so it's a -1 charge. So it becomes Cl minus, okay, you could put a 1 there, Cl1 minus, but 1s are implied if there's no number, okay, so Cl minus, and is called chloride, okay, chloride ion, chloride, either way. So IgE, when something has a negative charge, -1, -2, doesn't matter how negative it is, negatively charged ions are going to end in ide, IgE. Okay. All right. Now we're going to talk about naming ions. I'm going to squeeze it into this space over here. I already talked about it a little bit when we went over those examples, but we're going to talk about it a little bit more. So positive ions as a group, positive ions are called cation. I'm just going to put that in parentheses, cations. Okay, cations. Positive ions, cations. These keep their elemental name. Positive ions keep their elemental name and gain the word ion. Positive ions keep their elemental name and gain the word ion. Negative ions, as a group, they have a name as well. Okay, positive ions are cations. Negative ions are called anions. anions, okay? And they have a name change. They don't keep their elemental name. We change the ending. So negative ions, element name, with the ending changing to "ide." With the element name changing to "ide." So element name with the ending changing to "ide." Okay. Now we're going to just throw a curveball at you. We made our color-coded periodic tables a little while ago. So this is my paper copy. Okay. Now all these elements in yellow, which is most of the elements on the periodic table, they have a special circumstance. All of them are positive. Okay. But most of those can have more than one charge. So they're not always a +1, like sodium's always a +1 because it only has one in its outer layer, it's going to lose it. Okay. The ones in orange, they have 2 in their outer layer, they're going to lose both of them, they're always a +2. But these ones in the middle are kind of funky, and we're not really going to get into what their atoms look like in this class, but they can have more than one positive charge. And because of that, we have to include their charge in the name, and we're going to use Roman numerals. So hopefully you remember your Roman numerals. If not, you have a chance to write them here so that you don't forget them. But those, remember, those yellow elements are called transition metals. Transition metals. And I think maybe it would help if you wrote yellow, because those are the yellow ones on our color-coded periodic tables. Okay. They keep their element name just like cations, because they are cations, they are positive. Okay, they're always going to be positive. They keep their element name and add a Roman numeral. They add a Roman numeral to tell the charge. To tell the charge. Okay. Keep their element name and add a Roman numeral to tell the charge. Now I'm going to scoot this I'm going to change the angle here just a little bit, scoot it down so that we can see some examples of this. Okay. So I'm going to put in Fe2+ and Fe3+, Pb2+, and Pb4+. All of these ions actually exist. And if we look at the periodic table, Fe is iron, but I can't call both of these iron because they're different things, okay? They have different properties. They're gonna have different colors for their compounds. They're very different things, okay? So we have to distinguish between one that's a 2+ and one that's a 3+. Now, by the way, 2+ means it lost 2 electrons. 3+ means it lost 3 electrons. Okay, 4+ means it lost 4 electrons. Okay, so that's where those numbers come from. If you see something without a number, it's assumed to be a 1, but anytime it has a number, that's telling you how many electrons were gained or lost. So iron, when it loses 2, it has a 2 positive charge. So we would call that iron, and then in parentheses, we would put Roman numeral 2, iron 2. Remember, Roman numeral 1 is just an I, capital I. Roman numeral 2 is 2 I's, capital I. Okay. Iron 3 would be 3 I's. Okay. Iron with 3 capital I's. So iron 3. We would just read this, iron 2, iron 3. Okay. Pb is lead. Lead 2 is Pb2+. And then 4+, it's not 4 I's. Hopefully you remember our Roman numerals. Roman numeral 5 is a V. 1 before 5 is IV, right? So this one is lead 4, which is IV. IV. 1 before 5 is 4. So IV is lead 4. Okay? All right, that's it for the ion notes. We are going to continue and practice with this in the next assignment. So snap a picture of your notes, upload it, and we will continue on. Thanks, everybody.